Innovation is at the core of the Port's long-term strategic plan and vision. We aim to become nothing short of North America's smart port. To achieve this, we are placing data and emerging technologies at the heart of our business processes.
L'administration du Port de Montréal a su tirer bénéfice de sa maturité numérique rapidement en réponse à la crise du COVID-19, de sorte à trouver une solution pour assister les premiers répondants sur la ligne de front du combat de la pandémie et du virus.
We are implementing an AI solution that identifies containers with critical medical cargo even before the vessel arrives at port.
Essentiellement, le projet consiste à identifier à travers les documents d'expédition des milliers de conteneurs qui convergent vers le port de Montréal les marchandises de première nécessité qu'on a besoin pour combattre le virus et de s'assurer que l'ensemble de la chaîne logistique est mis au courant de la présence de ces marchandises et de la disponibilité afin de s'assurer de sa distribution le plus rapidement possible.
Un des grands défis, c'est qu'il y a une surabondance de données et on a besoin de temps de réponse qui sont très courts. Et donc, on a besoin d'algorithmes pour rapidement traiter cette information-là, extraire ce qui est vraiment pertinent et arriver à soutenir la prise de décision.
And we do this by combining methodologies from two different fields, what we call operations research, that focuses on optimization of decisions, and from machine learning, that focuses on the prediction of the uncertain aspects of our system.
Ça nous donne l'opportunité de prendre du data, de l'information qu'on a en abondance ici dans le monde portuaire, dans la chaîne logistique, et de la transformer en intelligence. Alors, on est capable de faire un service qui est plus rapide et surtout dans le contexte du COVID-19, c'est vraiment un outil qui est indispensable.
The tool that's being developed right now between the Port of Montreal, Scale AI, and IVADO Lab really involves all stakeholders in all modes of transportation, including rail, trucking, maritime, and air freight. They will see that utilizing the data will help in their day-to-day life in moving freight in a more efficient and faster manner.
Pour nous, c'est une fierté de faire partie d'un projet comme ça qui va aider l'approvisionnement de la chaîne médicale parce que si ça peut aider à sauver des vies et à s'assurer que le matériel est là en temps opportun, c'est sûr que pour nous, c'est un bénéfice qui est vraiment intéressant à avoir.
The Port of Montreal is the second largest in Canada. It's also the fifth largest container port on the east coast of North America. It's a diversified port. Like many other ports or any other business, the Port of Montreal is fully committed to digital transformation and aims to become North America's smart port.
In one sentence, we are applied AI practitioners. What we do is to develop bespoke AI software solutions that use state-of-the-art mathematical algorithms, which are mainly a combination of machine learning and optimization to solve very complex supply chain problems.
So Canada, like many other countries, is facing a significant deficit in personal protective equipment since the beginning of the pandemic. While this PPE equipment was transported by air in the early phase of the pandemic, the maritime will be called upon to play an increasing role to provide and supply PPE to frontline workers. The objective of this project is very simple. It's to save lives. So we aim to fast-track containers containing critical medical cargo from the time the vessel arrives to the time that the container is actually out the gate of the port. So let me tell you about the vessel berthing process and how the information is transferred along the chain. So 96 hours prior to vessel arrival, the ship captain sends all the manifest information for the containers on board the vessel. The algorithm immediately goes to work and starts filtering the contents of the vessel going through numerical HS codes and textual description of cargo on board. Once the vessel is berthed, we have a dashboard that will track and trace containers as they're offloaded all the way through their exit of the gate.
We have world-class scientific advisors who ensure the quality of our solution design, and we have hybrid teams of data scientists, data engineers, software developers, and product managers who would bring the solutions to life. Finally, we partner with our clients. We partner with our clients to help them use AI solutions into their day-to-day operations and decision-making. And as part of this partnership, we also make sure to help upskill their talent so that they would be able to operate and own the AI-powered solutions in the long run. Natural language processing, or NLP, is a subfield of artificial intelligence that mimics human language abilities. In simple terms, NLP represents the automatic handling of natural human language like speech or text. The reason why we use NLP is that a few days before containers on the ships arrive at their destination ports, there are multiple sources of data coming from various stakeholders that indicate what the content of that container should be. In an ideal world with perfect data, meaning no quality issues nor missing values, we wouldn't have needed any of this. Unfortunately, supply chain data is notoriously hard to reconcile, and COVID would just not wait for the perfect data exchanges in the supply chain to happen. In such situation, one faces two options. Either the human manually combs through massive amounts of unstructured data to identify, validate, and tag critical cargo, or you speed up the process using some sort of technology. The problem is like finding a needle in a haystack, and what AI does is that it reduces the problem to finding the same needle in a handful of hay. The process can be summarized in 5 steps. To get started, we created a reference list of HS codes along with their text descriptions that were defined as the critical goods by the government. The HS code, or Harmonized System Code, is an international product nomenclature that describes the type of goods that are being shipped. This initial list was mainly for medical goods, but obviously that can evolve over time as the needs and the priorities evolve, such as food or agriculture. As a second step, we joined various sources of data that would give information about each container, either in form of HS codes or text descriptions. This information is not necessarily available for all containers, and even then, the quality might not be reliable for identifying critical cargo. Then the NLP algorithm kicks in. In this step, the AI model will ingest all the information about each container and understand the context so that it can make a recommendation what the container cargo type should be. The model recommends the top HS codes that are likely matches to each container. In step 4, the solution flags the critical cargo, which means comparing the top recommended HS codes against that initial reference list. Here, the end user's tolerance for false positives determines how far down that recommended HS code list the model should look for a likely match. The final step is called the human in the loop. The business user validates the solution's output and identifies the false positives. Here, we can also prevent some of those results from reappearing by adding certain keywords to a blacklist. You can think of an example where we are looking for surgical masks and the model flags Halloween masks. Or we are looking for alcohol and the model flags vodka and whiskey, which is definitely not what we are looking for.
So some of the challenge and lessons learned during this project, firstly, AI is not a plug-and-play solution. So the 10-week project duration was a challenge in itself. The project, obviously, the solution design and development required many iterations and fixes and bugs before the solution was ready to put into production, which is absolutely normal for this kind of project. Another issue and challenge was accelerating and fast-tracking the funding mechanism. So I really salute our partner IVADO Labs for jointly doing this with us in a record time.
I would like to categorize the lessons learned and challenges into 4 categories of business, data, science, and engineering. On the business side, I would mention that the project was not planned. It was something that we had to very quickly put together due to COVID. As a result, finding the right staff, financing, and planning was extremely challenging. On the data side, a lot of the data sources in the industry are not easy to obtain and often require very heavy data engineering before doing any data science. For instance, there are various EDI sources. There is lack of centralized information distribution, and sometimes there are noticeable differences in standard formats of the data. On the science side, I would say it could be a big potential challenge that fortunately we did not face. That was thanks to our previous AI project experience with Port of Montreal and also our deep expertise with the broader ecosystem. Finally, engineering was our biggest challenge. What we needed to accomplish in an extremely short time frame was not only to develop the science and to prove it works, but also to develop a functioning software solution that had to be usable for the end user at the end of a 10-week exercise. While we delivered on the science portion in time, the engineering, user experience, and the UI side ended up needing more work that we had to quickly catch up on afterwards.